Hello, this is Camille Fairborn from Michigan State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. I'm pleased to introduce Mikaela Meyer and Ciaran Evans as our presenters today. They are both PhD students in the Statistics and Data Science Department at Carnegie Mellon University. For today's webinar, they will give a presentation entitled Introducing Think-aloud Interviews as a Tool to Explore Student Statistical Reasoning. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box, and we'll be sure to ask those questions towards the end and give our presenters a chance to respond. You can also use the chat box if you're having any technical questions. So at this point, I'll turn things over to our presenters. Ciaran, go ahead.
Hi, everyone. Thanks so much for coming to the webinar. Today, we're going to be talking to you about some research that we've been doing that uses Think-aloud interviews to better understand how students think about statistics. So this research has been conducted as part of the Teaching Statistics Research Group at Carnegie Mellon. And over the last few years, our group has been working on using Think-alouds to explore student misconceptions and write assessment questions. In this webinar, we'll talk about some specific misconceptions in introductory statistics that we've seen, and also in an undergraduate mathematical statistics course that we've explored through Think-aloud interviews. And if you're interested in learning more, we've got a paper on archive, and there's a link to that paper at the end of the presentation. So I've mentioned statistical misconceptions, and we know that these can be a pretty big deal. So if we look at what people who use statistics often do, we can see that there's some issues in how they understand statistics. So I don't mean statisticians, but sometimes scientists or researchers who use statistics for their work. So for example, there's been research in the stat ed literature that indicates that scientists often don't understand confidence intervals or how to interpret error bars that they put on estimates. And if we look at some of the problems that several fields have had with things like p-hacking and data manipulation in recent years, we can see that there is a gap between maybe what we think we're teaching and then how people actually use statistics in the real world. Now, our first chance to address and correct misconceptions comes in undergraduate level classes. And we know from previous stat ed research that there's a lot that our undergraduates are confused about. So for example, there's confusion about probability and about sampling distributions, about p-values, about confidence intervals. You know, you can sort of keep going on with this, but there's been papers for all of these that sort of suggest that our undergrads don't always understand these concepts. But in the content of undergraduate classes does change over time. And also to address misconceptions, we sort of might want to try to change our teaching strategies, or maybe to try out different interventions. So it's still important to conduct research on what misconceptions our students have. And also it's important just to understand how our students think. So it's not just enough to know what students don't know, but also we want to know what they think about those concepts in order to figure out how we can teach better. So as one of the members of our research group puts it, we can only defeat statistical misconceptions if we understand them. So then the question is, how do we research what students do and don't understand? Well, one of our research tools has been to talk to students using Think-aloud interviews. And in Think-aloud interviews, we have students answer questions and, as the name suggests, think aloud as they work to help us see what their thought process is. So here's a few quotes that we have from students from Think-aloud interviews here when they're trying to answer a question about sampling distributions. And you can see that, well, for the selected quotes here, the students were kind of confused about what sampling distributions really are. So let's take a look at that second quote there, where the student says that small n means few bars in the histogram that they were presented with. The student thought that the number of bars in the histogram actually reflected the sample size. And so their entire answer for this question was based on matching up sample size with the number of bins in the histogram. So if we just looked at their answer alone to that question, we wouldn't really be able to tell that that was what was going wrong. We'd be able to tell that they got the question wrong, and maybe there's something they don't understand, but actually figuring out that it's because they don't understand histograms, and that prevents them from answering a question about sampling distributions, we wouldn't be able to tell without having those students think aloud as they work through the question. Now, to carry out Think-aloud interviews, we recruited student volunteers from introductory courses, and we conducted hour-long private interviews with each of those students individually. And during an interview, we had students work through a series of questions and talk about their thought process as they worked. And while they were doing that, we didn't give them any feedback and didn't ask any follow-up questions until the end of the interview, so we could try and get as best as possible what their thought process really was without any interference from us. And it's important to try and get their thought process as they work through the question, because it turns out that the way that students think about a problem differs when they actually do a problem compared to when they solve a problem and then try and justify their answer after the fact. So we can learn more about why students get an answer right or wrong. And we can also hear how confident they are in their responses if we can actually hear their thought process as they go through the question. And this is also a useful tool for getting feedback on the questions themselves. So for example, if we want to use a question later on in something like a concept inventory or an assessment, well, we'd like to actually trust that what we think we're asking in that question is what students are interpreting that question to mean when they try and solve it. So if there's any issues in the way the question's worded or anything that's confusing the students, so they're getting the answer wrong, not because they don't understand it, but because they just don't like the question, then we can try and figure that out from ThinkAloud interviews. And we'll talk more about that later in the presentation. So now that we've done a little brief overview of what ThinkAloud interviews actually are, I want to talk about one of the misconceptions that we've been looking at for introductory statistics, which is correlation versus causation. So the difference between correlation and causation is an important part of statistical reasoning, and it's something that we often stress in introductory courses. And I think that some of us who have taught intro stats think about correlation and causation, or at least how we impart it to students, like the XKCD comic that I've shown you here, where students don't know the difference between correlation and causation before they take a stats class, or they intuitively conflate correlation and causation. But then they take stats and they think that, okay, now I can't do that anymore. And they've learned some lesson that correlation does not imply causation. Maybe we can sum it up just in that phrase that Randall actually wrote in this comic here. But maybe we don't have a very specific sense of what our students actually think. So we'd like to try and figure out really what specific conceptions and misconceptions our students have on correlation versus causation. And this is because student understanding of correlation and causation isn't just binary. It's not they didn't understand it before they took the class and now they do. There's lots of nuance in correlation and causation. There's lots of possibilities for how students might think about relationships between two variables. So I've listed just a few possibilities on the screen here. It might be that students think that correlation means causation, that they intuitively think that you observing a relationship means that there's something causal to that relationship, which is sort of that naive state that was in that XKCD comic before. Or on the other hand, they might actually swing too hard the other way, and they might become too skeptical after taking our course that correlation could ever imply causation. So maybe they internalize from intro stats that we should never draw causal conclusions in any circumstances. And sort of both of these are a problem, because on the one hand, we do want students to be cautious. We don't want them to just be drawing causal conclusions left, right, and center. But on the other hand, they actually do need to understand that researchers can still ask causal questions under the right circumstances, and that's one of the things that statistics gives us. And of course, these aren't the only two possibilities either for what students understand. It might be that maybe students learn some terminology about causation and randomization, but they don't really understand it at a deep enough level in order to make the right judgments in new situations. So to try and see what sorts of misconceptions students had, we wrote a set of questions on different aspects of correlation versus causation and randomization, and then we gave them to students in ThinkAloud interviews. So I've got on the screen on this next slide here, just a couple of the questions that we asked. So in the first one, we're asking about a randomized control trial. And because it's a randomized control trial, it's reasonable that we might start to think about causality. And then the second one, we have an observational study, so maybe it's not appropriate to draw causal conclusions. We also drafted other questions to see what students knew about the role of randomization, whether they could correctly identify inappropriate causal conclusions, even when we drop words like correlation and causation, and some other aspects. So there's more about that in the paper that I've linked to at the end of the presentation here. But basically, we're trying to get at these different aspects of correlation and causation and drill down into specifically what students know and don't know, not just whether they get these questions right or wrong. Now, the preliminary results from these ThinkAlouds are interesting. So they suggest that students tend to be too cautious and they don't want to draw causal conclusions, even when they're justifiable. So for example, here's some of the quotes we have from students who did these ThinkAlouds on these questions, We can see that they're cautious about saying correlation implies causation, which is good, but it seems like they don't really know that you can still draw causal conclusions in some circumstances. So for example, they say, when can we ever say that something causes something else? They think that their friend who's a stats major told them that you can never say something causes something else. There's always confounding factors that are at play there. And so it seems like maybe they've veered too hard the other way in being too cautious about drawing causal conclusions. Now, of course, these are just results from ThinkAloud interviews, which are really useful at looking at student thought processes, but there's a little bit of difficulty scaling them up. And so to try and scale them up, what we did is we took some of our questions from these ThinkAloud interviews, and we gave them as multiple choice questions in an assessment to hundreds of intro stats students. And we found some of the results similar to what we saw in the ThinkAloud interviews. So again, here's that question on books and nearsightedness. And because it's an observational study, the correct answer is that we shouldn't draw causal conclusions from it. And 87% of our students got that question correct. But on the other hand, we have this other question about a randomized control trial. And we want students to say that, well, this supports some evidence of causal conclusions here. But still, a majority of the students are saying that we can't draw any conclusions because correlation does not imply causation. And so it seems like even in the case where you should be able to say something or start to think about something causal, students still are pretty hesitant to say that. They still want to say that correlation does not imply causation. So through ThinkAloud interviews, we can get a better sense of what our students actually think about this topic in statistics. And then having tested our questions with these ThinkAloud interviews, we can also feel confident that those questions are asking what we want them to ask. And we can use those questions then in a larger scale assessment to see if those sorts of misconceptions hold in a larger group of students than just the ones who participated in our interviews.
So ThinkAloud interviews, as Ciaran was explaining, are helpful to find out whether students in our intro classes understand the concepts that we're teaching them. But it could also be useful to know how experts are solving introductory level statistics problems. Because if we know how experts are solving these problems, this might give some insight as to how experts are teaching novices. And it also gives us a better sense of the eventual thought process that we want students to be able to use. And so the process that we used for this project was the same as Ciaran's, where we were having students in ThinkAloud interviews participate for about an hour, and it was just the interviewer and the student. But in this case, we were using cognitive task analysis as well as the ThinkAloud interviews to get a better idea of which steps in the problem-solving process are most difficult for students to follow. So cognitive task analysis is a method from cognitive science research that is used to outline the steps that people take when solving a given type of problem. And so for the purposes of this project, we were interested in outlining the steps that students take to solve problems where it's important that they can identify the relevant variable in the problem. So for example, when students are calculating a marginal distribution from a joint distribution, we wanted to know, do they know what to integrate with respect to? You know, if they're finding the marginal of X, but they're given the joint distribution of X and Y, do they know to integrate with respect to the correct variable? So on the right side of this slide, we show the steps that we expected students to take while solving these problems, which were generally that they would identify the relevant variable in the problem and the necessary rules to solve it, and then they would apply the rules and solve the necessary math. And we decided to use ThinkAloud interviews again to determine whether these cognitive tasks were identified and ordered correctly, because if we know which steps students are skipping or struggling with as they're solving these problems, this information can help us better target our teaching efforts in this course. And so thus far, we have conducted ThinkAloud interviews with 8 PhD students in statistics for this project. And we view the steps that they took while solving the problems as the steps that experts would take to solve them. And we've also conducted ThinkAloud interviews with 16 undergraduates who were enrolled in Carnegie Mellon's Introduction to Statistical Inference course at the time of the interview. And here's an example of one question that we asked during the interview. We gave everyone the log likelihood for NIID samples from a univariate normal distribution, and then we asked them to calculate the maximum likelihood estimator of the mean mu. So sort of a classic MLE problem. And so 3 experts answered this question, and they all got the correct answer. And the experts seem to have a stronger sense and an awareness of what was happening in the problem. And this might be because they've seen questions like this in the past. So some of the experts came in and started the question and said, I know that the answer is going to be mu, but now let me solve it. But because they knew what the answer was going to be from the beginning, that meant that they could easily check their work at the end. So even if they did make a miscalculation somewhere along the line, they could go back, find that, and correct for it. Now, 11 novices that we interviewed answered this question, and only 4 of them got it correct. And all of the undergraduates remembered to take the derivative of the log likelihood, set it equal to 0, and solve for something, but they struggled with taking the derivative of summations and choosing the relevant variable for the derivative. So when you're looking at the log likelihood for this univariate normal distribution, there's a sigma term, a capital sigma, and it's for the summation, and students saw that and didn't really know what to do and froze. And we noticed that 3 of the students who answered this problem incorrectly also missed an earlier math problem that we gave them that involved also taking the derivative with respect to a capital sigma sum term. And in general, novices struggled because they either felt uncomfortable with the math steps or they struggled with identifying the relevant variable in the problem. So they didn't know whether they were supposed to take the derivative with respect to mu or with sigma. So we're still working on transcribing the ThinkAloud interviews from this project, but we plan on qualitatively coding the transcripts based on our original cognitive task analysis from the previous slide to see how the undergraduates differed from the experts and how we can improve our lesson plans based on these differences. So ThinkAloud interviews are useful because we can get a better sense and a better understanding of student thought processes more than we could by just observing what their answer to a question is on an exam. But the problem with ThinkAloud interviews is that they're not a very scalable research tool. So we would like to be able to give these questions to a large number of students, like Ciaran was talking about earlier, and trust that their answers tell us something about how they're thinking. So fortunately, ThinkAloud interviews are also useful for testing out questions, because we can observe whether students got a question right because they actually understood what was being asked of them and actually understood the material, or whether wrong answers indicate specific types of misconceptions. And this sort of then creates a loop of writing questions, testing them with ThinkAlouds, rewriting the questions to address the things we found in ThinkAlouds, and then testing them again. But why exactly is it hard for us to write questions? Well, as we learn a subject, we develop mastery of that subject. We start off with unconscious incompetence, where we don't know anything and we have no idea what we even need to learn. And many students enter our introductory courses the same way. But as we learn more, we move to conscious incompetence. We're aware that there's a lot that we don't know and a lot that we need to learn. And eventually through practice, we get to conscious competence, where we are competent at the skills we're learning. We have to think carefully about our work and figure out all of the steps, but we can do the task. And then finally, we become experts. We develop unconscious competence, where we know how to do everything and it's basically automatic. It can be hard for us to explain how we chose to solve a problem a particular way, or how we did certain steps and why we chose to do certain steps, because we essentially just do it automatically. So a good example of this is driving, which you do essentially automatically. You're not really thinking about all the things that you're doing as you're doing them. And I'm sure many of us are the same way with introductory statistics topics. But the problem is that if we have this level of expertise, it's hard for us to write questions intended for novices. So we no longer know how they interpret questions or what approach they take to solve them. And this is the expert blind spot, where we've forgotten what was difficult and find it hard to relate to novices. This is particularly challenging when writing an assessment because we're very interested in spotting misconceptions in students, and those misconceptions usually arise in the first 2 stages of mastery here that we see on this slide. Knowing what misconceptions students are likely to hold and how to elicit them is something we do not automatically know how to do as experts. And education research in other fields, such as physics, has shown that students often understand and answer questions in ways very different from those expected by experienced instructors. Even questions that have been vetted by a whole group of experts sometimes elicit completely unexpected responses from students, which we'll look at now. So to give you an example of how ThinkAloud interviews can help us better answer and better ask questions of students, this is an example of one that we offered during ThinkAloud interviews. So we were trying to ask about independence without evoking the definitions used in the course or specific probabilistic language. And this was in case students could just parrot the definitions without having a full understanding. So we adapted this question from a textbook, and we weren't sure if this question would work, so we used ThinkAlouds. The goal here was for students to realize the draws are dependent because the draws are without replacement, without that being explicitly said. The question is a bit weird, but what we discovered from the ThinkAlouds is that students were confused primarily by the wording of the question. They weren't sure whether the first draw went back into the box. Some students just didn't know where it went, and so they ended up not being able to answer the question just because they were unsure of what happened. And that was not the confusion that we really expected from this problem. But fortunately, it was really easy to fix it. We just added ducks. So we just added a hungry duck who ate the first draw, and that made it explicit that the draw is now gone for good. Students ended up doing much better when answering this version of the question because it was clear what happened, and we were able to again communicate this idea of drawing without replacement without that being explicitly said. And so how did we do this? How did we know that students were confused in that way? Well, the thing is that we just had their answer choices from a multiple choice test. We really couldn't deduce that that's what they were thinking. And this is why ThinkAlouds have been so valuable. Without these interviews, we might have seen students answering this question incorrectly on an exam and assumed they just didn't know the material. Because it's so important to understand what students think is being asked of them, ThinkAloud interviews can help instructors draft more fine-tuned questions. In general, there were 3 different lessons that we learned about how to revise questions when conducting ThinkAlouds. When students identified minor details on the question that caused irrelevant misunderstandings, kind of like what we just saw in the previous slide, we knew we needed to edit the question a bit for clarity. So that was a pretty easy fix. But sometimes different students had various misconceptions about the same problem. And in this case, we decided to either split the question into multiple parts so that we could test each misconception separately, or we wrote new questions to adjust each misconception on its own. But again, it was important that we were making sure that we weren't incorrectly assessing 2 misconceptions at the same time, that we tried to separate those as much as possible. And also, sometimes students happened to get the correct answer, even though their steps were wrong. And depending on the question, that either meant that we needed to change some of our answer choices to make them less easy to eliminate, or we needed to really just kind of scrap and rewrite the question, or ask questions that were looking at maybe more intermediate steps to make sure that we understood that students were getting the right answer for the right reason. So in conclusion, we recognize that ThinkAloud interviews require a lot of resources. They're very time intensive because each of these interviews lasts about 60 minutes, and they require student volunteers in your courses, as well as enough interviewers to participate. However, despite these challenges, we think that ThinkAloud interviews are still worthwhile because they can give you insights about your students' misconceptions and thought processes that you might not have been able to get from just giving them an exam. So if you're interested in getting hold of the questions we designed for either the introductory statistics topics that Ciaran was talking about earlier, or for the statistical inference course that we were using cognitive task analysis with, we'd be happy to share these questions. Just reach out to one of us, and we have our emails at the end of this presentation. Going forward, we're also looking for research partners to help work with us to help collect data by either administering some of our questions in intro classes or letting us come to you to do ThinkAloud interviews with your students. For example, Ciaran this fall traveled to Colby College in Maine to collect more ThinkAloud interviews, and we would be happy to travel to other schools as well within reason. We also feel that we can use ThinkAloud interviews in other courses as well. For example, we're thinking of doing ThinkAloud interviews while students are analyzing a data set to see which steps they take, what stands out to them in the data set, can they point out outliers, etc. And we think that there are other courses that also could benefit from using ThinkAloud interviews as well, just so we get a better understanding of how students are understanding statistics concepts. So thank you again for joining this webinar today. Here's the link to our paper on archive about the ThinkAloud interviews and introductory statistics courses, which is more of what Ciaran was talking about at the beginning. And we also have a link to our website here where you can learn more about our research group and the other projects that we're doing. And we're willing to answer any questions you have now, or if you've come up with any questions later, feel free to reach out to one of us using these emails below. Thank you.
All right, thank you to both Ciaran and Mikaela for that really well-prepared webinar. Um, if you have questions for our presenters, please go ahead and type them in the question box right now. I think my biggest question was, yes, can we please get access to some of these questions that you've already decided were good questions? That's always something that I want, more help writing test questions. But personally, I've been really interested in the work that you guys have been doing, and I think that Michigan State is very close to Carnegie Mellon, and that we should talk some more, and maybe you should come visit.
Yeah,
I
that'd be
guess
great.
maybe, yeah. Just to have one question, for either one of you, what do you think was the most surprising misconception that you found so far in what you've been doing?
Ciaran, if you want to answer first, I'll go second.
Certainly. So it seems like, and maybe this is just me not having as much experience teaching intro students, but I was quite surprised at looking at correlation versus causation, what students understood about confounding variables. So we don't have much of that in there, but this is something that we've been looking at in the last couple of rounds of ThinkAloud interviews, is trying to get at what students actually think about confounding variables. And students, if they were to draw a causal diagram of what they think a confounding variable is one that influences the response, and that's it. They don't think about a confounding variable as one that needs to have some sort of causal influence on both the predictor and the response. And so they think that there's always confounding variables. At least it seems from the limited sample size we have of ThinkAloud interviews. It seems that students tend to think that everything has confounding variables because they can always imagine other variables that would impact the response, not thinking about how that other variable would also need to impact the predictors there for it to be something that maybe we want to worry about. And so the result of that then is that they're, I think, really cautious about ever concluding anything about causality, because they can always come up with other confounding variables. They can always list them for you, even in the presence of randomization. And then this ties into what they think about randomization as well.
Which is another can of worms altogether, I would imagine. Mikaela, what do you think?
For me, the interviews that I was doing the most were the ones for the mathematical statistics course. And I think the thing that surprised us the most from those was kind of what I was talking about, where the students really struggled with the math more than we expected. Like to a point where we actually went and checked like what the prereqs were for this course to make sure that like students had actually seen some of these things before. So I think one of the things, like again, where people were like just taking the derivative with respect to a sum, but they saw the sigma term and then weren't thinking of like, oh yeah, this is just like, if I was taking a derivative as if all of these things are just being added together, it really threw them off to see that term. And so another thing that was really interesting was that students kind of it didn't end up really hurting their ability to necessarily do the problem, but students did get tripped up on like the Greek letters. So they would see a Greek letter and they didn't necessarily know, like they couldn't really remember which one it was, or they totally like picked the wrong one when they were saying it, whatever. But I think even like little things like that, even if it didn't end up necessarily influencing like how they do the problem, like they just needed to recognize that that was a term. I think even little things like that can sometimes, make students maybe a little bit more nervous than we would want them to be when solving a problem. And so those were some interesting things that we found during our ThinkAloud interviews.
So do you think it would be safe to say that a lot of the times when we get depressed about why students are answering a particular way, that we're maybe misunderstanding why and putting the blame on the wrong spot?
Yeah, I think it's possible that, for example, in this case, like if we were to give the students this exam, like these questions as an exam, and they were messing up on the math, like if this was say just a multiple choice question or something like that, we maybe, or even if like they made a small mistake on the math or something like that, we wouldn't have realized by just answers that like they saw the sigma term and got totally confused.
Right.
So I think, yeah, they're like, for example, we've talked to the instructors who are planning on teaching this course next semester, and they seem more willing now to say include some kind of math test at the beginning of the course, just so that way they can see like what students know and don't know, so they can better spend time on that during the course.
That's really, really great. And I hope you guys keep going with this, and we're looking forward to seeing the research and the papers that come out of this. And I'm especially looking forward to seeing your vetted test questions. We don't have any questions from the audience. So again, I want to thank both Mikaela and Ciaran for their time today, and encourage all of you to have a successful end of this semester and a happy end of the year season. And we'll be back with more video or more webinars in the spring semester, and hope you'll all join us back then.
Thank you very much.
Thank you.
Bye-bye.